Hi, this is Dr. Don, and I have a question out of McClave, Chapter 7. And from reading the question, we're asked to do a test of the hypothesis, the null being mu, the mean of the population is 10, versus an alternative that the mean of the population is not 10. We have a sample of n equal 50, and the sample mean x bar is 10.7, and the sample standard deviation s equal 2.7. And we want to find the p-value and interpret the p-value. One of the things that catches a lot of people depends on how the problem is worded. In this problem, they tell us that we've got the sample standard deviation. That's what we need. Sometimes they will give you the population standard deviation in academic settings. In real world settings, you never know, rarely ever know, the population standard deviation sigma. So here we've got the sample standard deviation S, which simplifies things. Okay, well, what test do we run? Well, we don't know population sigma, and we've got a n that is 50. And so McClave differs from some other authors. Generally, most authors say if you don't know population sigma, you should run the t-tests. McClave says if your n is above 30, run the z-test. So let's see. Okay, I brought up StatCrunch, and I'm going to run the test both using a z-test and a t-test just so you will learn what's going on here. First of all, let's go with the z, and we go to stat, z-stats, one sample with summary, since that's what we have. And our sample mean is 10.7, our standard deviation 2.7, and our n is 50. We want our null to be mu equal 10. Our alternative is equal. And remember, you have a drop down there. If it's a left tail, you select less than. If it's a right tail, greater than. But this is a two tail, not equal. And I'm going to click compute. And we get our answer here. We get a z-stat test statistic of 1.833 and a p-value of 0.0668. Now watch that. Our alpha in this option here is less than 0.07. 0.0668 is less than 0.07. Therefore, you would reject. Wow, I almost stumbled here. They're really tricky on this question. Usually we're thinking of our p-value on the left and our alpha on the right, and I just read over that. This says you would reject the null for alphas greater than 0.07, which is our p-value would round to 0.07. So any alpha greater than 0.07 you would reject. The wording is a little bit tricky there, and if you stumble on that, I will look at what you do and possibly give credit. The second option there, alpha is less than 0.07. Since the p-value calculated is less than 0.07, that could be questionable. And the first option there, alpha equal 0.015, there is insufficient evidence to reject for alpha. Well, no, our p-value is 0.07. That is less than an alpha of 0.05. So therefore, this is kind of poorly worded. But the main thing I want you to get at is that this p-value for an alpha of 0.07 or greater, you would definitely reject it. Now let's look at the t-test. I'm going to go t-stats, one sample with summary. And here again, we've got a sample mean of 10.7, our x bar. Our S value is 2.7. And remember again that StatCrunch does you a favor and will calculate the sigma sub x bar for you. And our sample size is 50. Again, we want this to be 10 for our null. Our alternative is not equal. And I'm going to click on compute. And here we get a slightly different answer. They're close. The z-stats, both of them are approximately 1.83. Well, they're the same out to 6 decimal places there. But look at the p-values. 0.0668, which is less than 0.07, and 0.0728, which is greater than 0.07. So I think when they were designing this question, they were trying to see if somebody would make a mistake and use the t-test, and then if you got the t-test, you would get the wrong answer on both of these things. So just be aware that sometime in academia people play a few games. And just to refresh you again, McClave says, and it's McClave's book for our course, if n is greater than 50, even if you don't have the population standard deviation sigma, you can use the z-test. So I hope this helps.